All right. Hi, guys. Basir Balazade, ADEM TME. A little bit of a background on myself. I've been doing in tech for about the last 25 years. The first 15 years of my career, I was in the IT department. I started off with help desk, network admin, sysadmin, enterprise bat admin, worked for a bunch of startups. A part of me presenting this is because I've been there, I've done that, and I've seen it, and I remember how difficult. And one of the things I remember when I was doing my IT work was the dreaded call or the email that something is slow or I'm not able to access that application. And I remember back in the day, I had to log into a bunch of different tools, log into a bunch of different logs to look at that. Do you guys remember What's Up Gold, Zabbix, Nagios? So some of those things that I have to log into to be able to gain visibility or understanding of what's happening. And it would take me hours and sometimes even days to figure that out. And by the time I figure it out, people have moved on and nobody cared anymore, right? Because they moved on to something else it resolved itself. And that's where I've become super excited with working with ADEM because ADEM does a really good job of finding the needle in the haystack. And I'm certain so most of you guys are probably aware of this. For you guys that are new to this, I will do a quick overview of what ADEM is to create a baseline for everybody, so we're all speaking the same language, and then I'll talk about the RUM capabilities. So that was in the 2000s. In the 2010s, you guys are aware the cloud happened, and now we no longer have the visibility to the underlying infrastructure to gain visibility into what's happening. Now the network layer has been abstracted for us. And so when I did this in the 2000s, uh, I built the infrastructure. I deployed the hardware and the software. I built stuff in the data center. So I had visibility into the infrastructure. And so that's when in 2010s, I switched over from being IT to a TME, and I worked for a company called Gigamon. And one of the things I learned at Gigamon is unless you proactively go and build the infrastructure to provide visibility, it becomes very challenging to get those access to those packets once the packets have left, right? And so with the advent of the cloud, it's becoming more harder now because we no longer have access to their underlying infrastructure with SaaS applications. But we're still expected to provide the same level of SLAs to our users if they're working from home or if they're working from the office. And as I mentioned, when I was doing this, it would take me hours and hours and sometimes days to figure out what's happening. And so this is something that I've seen myself. I've talked to customers, and so the higher mean to times to detection is a challenge, and then the higher the mean times to resolution is definitely a challenge. And that's where I think ADEM does a really good job of helping with that. And one of the things that we like to refer to this is the delivery chain. So meaning from the user's device to the destination, there are multiple different hops that those packets have to traverse to get to the destination. And so how do you provide visibility into, is it the user's device? Is it their Wi-Fi? Is it their home ISP? Is it the SaaS application itself, the infrastructure for the SaaS? Where exactly is this problem to troubleshoot that? And that's where, when I did this, even in on our own infrastructure, it would take me hours and days to do that. I could just imagine now it's even harder to do that because that network layer has been abstracted with applications that are running in the public cloud. And this is where ADEM does a really good job of finding the needle in the haystack because we're able to gain visibility from the user's device all the way to the destination. And on top of that, ADEM is also a time machine that allows you to go back in time 30 days, up to 30 days, to see if there's a pattern, if there's something that's happening that is causing the problem. And one of the things I love about ADEM is when I was doing the IT things, it was always the network that was the problem, right? It was always the network that caused a problem. Nothing else was the network. ADEM does a really good job of saying, hey, wait a minute. Maybe it's not the network. Maybe it's the user's device that's having a hard time. Maybe it's their home Wi-Fi connection that's causing that problem. So ADEM does a really good job of finding the needle in the haystack. But then another revolution has happened, right? So we went from building infrastructures, deploying in the 2000s, 2010s, the cloud happened, which was awesome, made life easier, but also more complicated. And now I'm pretty sure you guys have noticed that most of you guys are doing your work in a browser. And that's what's happening with most of us is we are doing most of our work in a browser. And speaking of which, in 2020, I joined Zscaler as part of the browser isolation specialist because I saw this. I saw my wife working at when I went to her machine. I saw that she only had two applications open. It was Outlook and a browser. So she was doing her entire work in these two applications. And this is what's happening with your users too now with this advent of SaaS applications. Most of us are spending a lot of our time in a browser. And with that, how do we troubleshoot when you're on a microservices application? So these enterprise applications consist of multiple different microservices that come together to make that application, right? And so when you are performing tests to the application, the app is really good at providing insights into the availability of the application, the latency and jitter of the application. But what happens when you're on click 4 or click 5? How do you provide visibility into what's happening there? And that's where I'm super excited to introduce our ADEM real user monitoring capabilities and what benefits this is going to bring for you guys. Now, before I get into what RUM is, I wanted to talk about something that some of you guys may be aware, some of you cannot be aware. There's something called Core Web Vitals. This is where studies have been done on humans to understand what is our perception of a good loading web page versus a bad loading web page. And after many years of studies, the way humans perceive a good loading web page is if a page loads in less than 2.5 seconds. If the page takes longer than 4 seconds, I'm pretty sure you guys have done this. You will click the refresh button, you will go on to another tab, you will something move on, right? So this is the human psyche expects things to load in less than 2.5 seconds. So that's number one. That's the largest contentful paint. That's called the LCP. The next portion of it is interaction to next paint. Having the page load is one thing, but once that page loads, another thing that's being tracked is how long it takes for the page to acknowledge you clicking on it or you interacting with it. So that's another component. And the last component is the cumulative layout shifts. And this is where I don't know if you guys remember back in the day when pages were loading, it was loading. All of a sudden, the CSS would kick in and then it would reshuffle and move things around and then it would look pretty. So that's another component that's being tracked. So if a page loads in less than 2.5 seconds, awesome. If the page takes less than 200 milliseconds to interact, awesome. If the page takes less than 1 millisecond for before it shifts around, then that's awesome too. And so this is where this is a graphical representation of what I just talked about. The first part of it is how long it takes for the page to load. And this is a good page. It took 0.7 seconds. The next part of it is how long does a page take to interact, acknowledge that it's being clicked on or it's being interacted with. And the last part of it is the visual stability of the page. Now, with that said, what's become really amazing with our solution is now we have the power of synthetics. And so if some of you guys are not aware of what we refer to synthetics, ADEM performs 4 tests on the user's device. These 4 tests are ping, traceroute, MTR, and curl. So those are we refer to those as synthetics. And then now combining that with the real user monitoring extension that gets deployed into the browser, now we're combining the human aspect of it. So synthetics is machine-to-machine communication. RUM is human-to-machine communication. Combining these two together, we're able to provide a very powerful view into what is the problem with click number 4 or click number 5 of a web page. And then this is also able to provide more insights and more ammo or proof of innocence for the networking people to say, hey, you know what? It's actually not the network. It might be the application. And so the way I think about RUM is application performance monitoring from a user's perspective. Usually application performance monitoring is happening on the backend server to view that, but now we're extending the power of ADEM to provide us visibility into the performance of the web application. All right, so let me go ahead and get a little bit into the deeper dive into how does the extension work. Um, Initially, when we released this, it is a browser extension that is supported using our Prisma Access browser. And so in here, the way you deploy this RUM extension is through PAB itself. You go to the PAB configuration to do that. And as long as you have an ADEM license and PAB, then you will be able to utilize the solution. And this is, like I said, it's a browser extension that gets deployed into PAB, and from there, that's where we're able to provide the visibility. The extension itself has some intelligence and some capabilities on its own. So the extension itself is keeping track of the managing of the sessions, keeps track of the user activity, it collects this information, and then it sends it back to the ADEM portal every 60 seconds. So that's what the extension is doing. A part of that is keeping track of what's the CPU and RAM usage. For those of you guys who are familiar with ADEM, ADEM is bundled with our Global Protect agent. So the ADEM agent itself does that on your device. On your Mac and Windows device, it's able to keep track of your CPU, memory, disk space, Wi-Fi, some of those things. So that's the ADEM, that's the ADEM agent itself on your device via Global Protect. And then now we also have the Prisma Access browser ADEM RUM extension that's able to provide the CPU and RAM usage. As far as sessions, what we think of a session is a user ID, what domain they went to, when did they start, how long have they been there, and some of the all those activities. And the way for us a session is if a user does not interact with a tab for more than 15 minutes, then we consider that as the session is over. And then if the user goes back and refreshes that session or clicks on other things, then we will start a new session. So that's the way we think about sessions. 50 minutes of interactivity, then we start a new session if the user interacts with that page again. The next part of it is because we have visibility into every single click that the user is doing on those web pages, we're able to provide insights per page of how the performance of those pages are. And the performance includes that core web vitals that I talked about earlier. And I will show you guys this in a bit when I switch out of the slide mode. And the interaction is also the events, like your mouse clicks, what are you using to interact with the page? How long have those peripherals, are they introducing any latency into the interaction with the page? So it's not, so we're keeping track of the performance of the page, but also performance of the users, of the different peripherals that the user is using to interact with that page. Okay, now with that said, ADEM scoring has been enhanced to now utilize the RUM data that we're uploading into our portal. As I mentioned earlier, synthetics is machine-to-machine communication, whereas RUM is human-to-machine communication. And because now we have this capability, if we have the RUM data available to us, we're going to lean more towards the RUM data because that's human-to-human interaction. But if we don't have that, no problem. We still have other ways we still have our synthetics and to gather to use as a scoring mechanism. So one of the things that's changed is when we're doing those curl tests to an application, we're expecting HTTP codes between 200 and 400. So those are codes that we're expecting. If we see HTTP codes 400 and above, then we will assume that that page is not performing well. And so we will give that application of a score of 0. So that's right. And then the next component of it is time to first byte. Time to first byte keeps track of DNS resolution time, TCP connect time, SSL connect time, HTTP, a couple other things. And these are being tracked in milliseconds. And so again, that curl, the ping, the MTR, some of these tests that we're doing towards the web application, we're keeping track of those in milliseconds, and then we will use that. Now, if we do our calculations and it's a score of 70, awesome, we will display that on the dashboard. Now, if the score becomes fair, which is 69 to 30 or poor, then we start looking at the other components of our test to determine what can be the problem that's causing the degradation for the users for that website. This is now we'll start leaning on the synthetic information to give us insights to, is it the user's device that's causing the problem? Is it their Wi-Fi quality? How's their network? How's their ISP when we do the hop by hop analysis? So this is now our new scoring mechanism is if we have RUM data available, we lean towards that because it's human to human and human to machine interactions. If not, then we will stick with our synthetics testing. And with that, now we have several different ways that we can get insights into the performance of a web page for our users. This is the most ideal situation for us, where we have Global Protect installed on the device, we have the RUM browser extension deployed to PAB, and we also have a web application deployed. So in this scenario, we're able to get the most holistic view into the performance of that website from a user's perspective. Now, there might be some scenarios where you're using PAB standalone and you don't have Global Protect installed. And so this is where, remember I talked about earlier, where the extension is able to provide us visibility into the CPU and RAM usage of the device. Now, this is when PAB is running in a standalone mode, we're able to provide insights using that browser extension. The next part of it is the existing scenario where we have Global Protect deployed on your user's device, and then we also have a web test. So this is the existing scenario that you guys are used to. And the last portion of it is we have Global Protect installed. We have the RUM browser extension installed, but there are no web tests deployed. And in that scenario, then we will provide some synthetics and RUM combined together to provide insights into the performance of the machine itself, right? The ping, trace routes, one of those things. All right. Now, with that said, I'm going to stop my sharing and show you guys what I mean by the extension itself. And so if I go to inspect, by the way, this is one of my favorite web pages that I go to, electric.co. When you go into inspect in any Chromium-based browsers, you will see a new tab called Performance. And in Performance, this is where we have the core web vitals available for us. And so when I loaded this page, it took 1 second. But it took 1 second to do the cumulative shifts of the page. So that's a bad score. Remember, we're expecting 1 millisecond, not 1 second. And then when I click, so if you see this part right here, it's blank. When I click on the page, it took 60 milliseconds for the page to acknowledge me clicking on it. So now let me click on it again. Let me go to another page. All right, this one loaded really fast. Let me go ahead and click on here. 60 milliseconds for it to load. So that's what it's the RUM extension is tracking. Is look at that. That got a pretty bad score. That took 6 seconds to load. I was actually ready to refresh the page because I was like, wait, did I click on it? What happened? Why isn't it loading? So me being a human, I was expecting this thing to load in less than 2.5 seconds, and I was about to refresh the page because it wasn't doing what I was expecting for it to do. So yeah, that's what it is. This is where the RUM extension that is deployed, I'll show you guys. Here it is, right here. This extension runs in PAB, and it's able to provide us visibility into, or insights, this core web vitals insights into what's the performance of the individual pages. And this is how we're able to provide insights into not just the availability of a web page or how's the performance of the page. How's the availability of the page, but now we're able to provide insights into how's the individual pages that are loading for the user's perspective for us to gain insights into that. All right, with that, I'm gonna play you guys a quick video going over what it looks like in our dashboard, and then we'll come back. All right, so let me go ahead and double click on this. Did not mean to do both of them. Let me do this one. This is a webinar that Ankur did earlier, and so let me just go to full screen and push play.
Now let's show you how it looks like on the ADEM dashboard. So if you log into the ADEM dashboard on Strata Cloud Manager, you come to the organization view. This is where you see overall mobile users in your network, how many devices they are connecting from, how many domains they are accessing from all of the devices in the network, how many domains are performing good, fair, or poor. We also automatically highlight what are the top 5 apps which are having the most degraded experience in terms of number of user devices being impacted and the time it is impacted. So you know which is the most poor performing domain or an application in your organization. But another key metric is how much time your employees are spending on the browser in the organization. And about the total time, how much time is being good, fair, or poor. So we have a breakdown of every single time a user is spending on the browser and how much time is again good, fair, or poor, and how many domains are performing good, fair, or poor. But at an organization level, we provide again the core web vitals for an application performance on the browser. What's your median largest contentful paint time? So at an organization level, I can clearly see it's 2.2 seconds, which is good. And at an organization level, I also understand what's my interaction to next paint. That means when I'm interacting with an application, how much time is taken to respond. Even that is looking healthy. So where is the problem overall in an organization? If we scroll down, we will quickly see the root cause analysis. This is where we say that how much time, hours which is spent, which is having a poor experience on the browser, breaking down. Is it because of device issue? High CPU in this case, how many users are impacted because of high memory consumption? How many hours has been impacted and how many domains are impacted? Is it because of a Wi-Fi issue, LAN performance issue, internet, or an application itself? So all the time which is not working well on the browser, we have a clear breakdown of device, Wi-Fi, LAN, internet app issue at the organization level, how many users impacted, domain impacted by a specific segment. But this was an organization view. How can we get per user view? If I click on a single user on the organization page itself, we can land on to per user experience visibility. In this example, this is Daniel Reed having a poor performance on one of their laptops. If you look at it, Daniel Reed has 2 devices, one a MacBook and a Windows. Windows is performing fine, but MacBook is having a degraded performance. Now, when I click on the MacBook, I get all the data and the experience for Daniel Reed on the MacBook for all the applications which Daniel would have access. So first, how much time impacted in last 24 hours for Daniel on the MacBook Pro? And all the time which is impacted in last 24 hours, is it because of device, Wi-Fi, or local network? What are the top domains being impacted for Daniel on this laptop? And then on the first example, if we go to a ServiceNow as an application, we can clearly see the data is coming from RUM, which is a browser RUM, as well as synthetics, which is continuously being run, mimicking user behavior from the laptop. There are 3 pages which Daniel accessed from the MacBook for this application. Further coming down, we can see that total hours spent by Daniel on the MacBook Pro for this specific application, how much time is being spent and how much time was good, fair, and poor. Again, single user, single device, single application domain, how much time is spent, how many pages accessed, which page is performing good, fair, or poor. And then what's the root cause of that page not working well for Daniel? So we clearly give the device Wi-Fi application, how many pages impacted again on that device for that domain for Daniel. We clearly show the topology all the way from device, Wi-Fi, local network, internet, application, and ServiceNow. So we clearly know what segment could be a problem. When I click on a page experience, we can clearly see at a given point in time, because browsing is something user will not do continuously all in 24 hours. It will be very sporadic. Whenever they open a browser and they go to an application, we capture their transactions and we can clearly see how many pages at a given point in time is performing good or degraded experience for that particular domain at a given point in time. And if I go to a degraded page, it clearly tells me that specific page at that moment in time, what was having a problem. Is it a page load time? Largest contentful paint was an issue. Time to first byte was an issue. Is it a Interaction, which was a problem, interaction looks healthy, but looks like the cumulative layout shift and the largest content paint was a problem for that specific page within the ServiceNow application. And the root cause is because user was having a poor Wi-Fi. So at an organization level, all domains, all users, devices, which is the domain having the poorest experience, what's the root cause, and then you can drill down to per user, per device, per domain, per transaction, and per page, which is having the poorest performance. So that comes through Prisma Access browser, users accessing an application any given time from the browser.
All right. Thank you, Ankur, for that. Let me go ahead and close this. All right, so far what I've talked about has been for Prisma Access browser. We're getting very, very close to being able to release this for commercial browsers such as Edge and Chrome. And for that one, I've also created a video for you guys to watch to see how easy it is to be able to do this once it becomes available for you guys to do this for Chrome. And so in this scenario, we're going to be using, we're going to have this deployed to a managed device. And in this video, we will talk about how to use JAMF to do the configuration. We also have the setup also for Intune too, but I'll just go ahead and play the video. You guys can see it. Again, I did not mean to double click. Let me go ahead and full screen this one. Let me show you how easy it is to get the new RUM browser extension deployed to a Chrome or to an Edge browser that's running on a managed device. We'll go ahead and click on Settings. From Settings, we'll go to Access Experience Management. For those that are not aware, this screen provides us a view into devices that are being monitored by ADEM. Now we have this new icon called Manage ADEM RUM Plugins. On this screen, we provide a list of MDM solutions and step-by-step directions. We have instructions for JAMF, Google Workspace, Microsoft Registry, and we'll also provide PowerShell scripts for Microsoft Intune or Workspace and manual deployment. The customer can pick and choose if they want this to get deployed to their Chrome or Edge browser. Let's just go ahead and I'll show you each example. So we'll stick with the JAMF, click on Generate. And this is where we provide the step-by-step directions and scripts that the customer can copy and paste to put into their MDM solution. All right, that was for JAMF. Here's for Google Workspace. Same idea, same concept where we can provide the step-by-step directions and the customer has the ability of copying and pasting that into their MDM solution. For Microsoft Registry, this is the registry key that will get downloaded onto the machine. Basically what this does is it provides a guidance to the Windows device on where to go and find that extension in the extension store. But on top of that, we also provide a PowerShell script that the customer can use to deploy into their Intune or Workspace one solution. And the last one is the manual option. If the customer doesn't have an MDM solution and they want to manually get this installed. So this is for Mac OS. This is the equivalent of the registry key that we provide for Windows. In this portion of the video, I'm going to quickly go over how to configure JAMF to deploy the extension into a managed device. First, we'll check to make sure the device is registered. Next, we'll go ahead and create a new configuration profile. We'll go ahead and name it and give it a description and choose the method of how to deploy the agent. We'll stick with automatic. Next, we'll go ahead and upload the payload and the configuration that we copy and pasted from the ADEM portal. We'll go ahead and assign the new profile to a user and a device. We'll repeat the same steps for our Edge browser. And once that's done, we'll go ahead and check to see if it's been successfully deployed. Now let's take a look at it on what it looks like on the device side. We see that the profile has been deployed, and now let's go ahead and check on our browser. We see the policy first, then we'll take a look at the extensions, and there it is. It was that simple. Once this is done, we'll go into the screen that will allow us to manage RUM. Go ahead and click on Done. We'll go to Insights, Application Experience. And in here, on top, we have the Manage Tests and RUM. You guys are used to seeing Application Suite. You're used to seeing the application tests. Now we have a new tab called Browser-Based Real User Monitoring. In here, we have the ability to either disable the RUM capability for the entire tenant. We can pick and choose which domains we want the RUM monitoring to work on. So this is a new functionality and feature that is being introduced now, where we can pick and choose the domains to monitor. And we could also add a new one if we wanted to. I'll go ahead and just do AOL.com, hit enter. The domains that are unchecked will not be monitored. The domains that are checked will be monitored. And on top of picking and choosing which domains, we also now have the ability of picking and choosing users that we want the RUM monitoring to work for. And that's it. It's that simple. Once that's done, now let me quickly show you guys what it looks like under the dashboards. Let me go ahead and scroll down. I'll pick this user. And this user, now we see that whatever sites they're browsing that we are monitoring, we will also see which version of the browser that they're using for us to monitor. In some instances, we'll see maybe all three browsers in PAB, and Edge, and Chrome. And that's it. It's that simple. All right. That was it.